Einstein's Relativity, Part 9. Light Speed and Acceleration. Special relativity only applies when there is no acceleration at the source of light or light's receiver. A non-accelerating system is a rare circumstance, since most objects, or frames of reference, are moving in circles, which means that they are changing direction, which also means they are accelerating. This is true of the rotation and course of moons, planets, stars, the Milky Way, and all observable galaxies. Spacecraft may theoretically move in a straight line along with an infinite amount of debris in outer space, and Einstein's imaginary frames of reference. That is what special relativity applies to. Even these will eventually be subjected to forces that will curve their route, except for Einstein's imaginary frames of reference. Faced with this fact, Einstein was obliged to address acceleration. I wondered how Einstein's theory addresses the speed of light while the emitter or receiver is accelerating. I found this Q&A. The link is posted at the end of this video. Roger asks, one of Einstein's thought experiments involved a rocket and two light sensors inside a rocket, one at the top and one at the bottom. When the rocket was at rest, a pulse of light from the bottom sensor travels to the top sensor at the speed of light c. But when the rocket is launched and is accelerating, it takes the pulse of light longer, or c-, to travel from the bottom sensor to the top sensor than when the rocket was at rest. John Renai answers Roger, the local speed of light is always c. By this I mean that if any observer, anywhere, measures the speed of light, they will get the value c. It doesn't matter if they are accelerating or not. However, for an accelerating observer, the speed of light at distant locations will not be c. Renai is almost making the point that I have been making in my videos. I have conversed with many people over the years who maintain that light speed is relative. But Renai's statement is the first I have ever heard from an advocate of Einstein's relativity that the speed of light at distant locations is not c. Amazing. Within the vacuum chamber of any light velocity measuring device, I am comfortable saying that all parts of the device are local, and I do not question the results of those experiments. An oscilloscope is one such device, with a light source sending a laser beam a distance to a receiver. If the device is accelerating, the result will vary. If we get light speed variation, according to John Renai, we can say that the light source of the experiment is not local to the receptor because of the variation due to acceleration. The receptor is moving at a different speed because the device accelerated after emission and prior to reception. This correlates with the evidence of the Jupiter-Io eclipse as viewed from Earth during separation. The speed of light at distant locations, Earth and Jupiter, will not be c, as viewed from the other. This is also demonstrated in my video, Two Big Clocks. Let's stay with Roger and Einstein's thought experiment of a rocket with a light source at the bottom and a receiver at the top inside the rocket. Here I give you 4 rockets. Since this is a thought experiment, we can say the rockets are 300,000 kilometers from light source at the bottom to the light receiver at the top. Rocket 1 accelerates up as the one John Renai commented on to Roger. Rocket 2 accelerates down. Rocket 3 is at rest relative to John Renai and anyone looking at the video. Rocket 4 is moving up relative to 3, but not accelerating. All 4 rockets are equal distance from John Renai, who is able to trigger a radio signal for all 4 flashers to flash at light source of all 4 rockets. At moment of flash, Rocket 1 will accelerate up. John Renai said it will take more time for the flash to reach its receiver. Rocket 2 will accelerate down. Galileo and I would say it would take less time for the flash to reach the receiver of 2. We all say it would take 1 second for the blue light of Rocket 3 to reach its receiver, and 1 second for the red light of Rocket 4 to reach its receiver. Galileo and I would say it will take less time for the red flash to reach receiver 3 and more time for the blue flash to reach receiver 4, because Rocket 3 and 4 are not local to each other. Not local is John Renai's term. This tells us what John Renai said. The local speed of light is always c. However, the speed of light at distant locations will not be c. Light speed is always c when the transmitter and receiver are at rest with each other. Otherwise, the speed of light is relative.